Hello everyone, here we're gonna talk about a project I have developed for electrical design. Uh, this is a product I have developed. Uh, this is a humidity light intensity sensor with webcam monitoring, and it is Arduino based. So to utilize Arduino I have used ESP-32. As you can see, it is residing inside this enclosure, and webcam is accessible from outside. Same for DHT11 for temperature and humidity, and for light intensity sensor I'm using LDR module that is accessible from outside. As you can see from it is accessible from outside of the enclosure, and it has a plug-in plug-out connector, so in case of repairs or faulty components, easy to replace this sensor. So as you can see, that easy to remove and replace. So and this is USB-C is accessible from outside, so without opening this enclosure we can use this whole setup. So let's now dive into software side of the design. So I would open Arduino IDE. Here you can see that I have included some libraries for Wi-Fi and DHT sensor, and same for ESP camera, which is inbuilt on ESP-32 Wrover board. First of all, I have defined camera pins that is included in .h file here. So for different types of depend on a module, there are few on the market. So mine is this one, camera Wrover kit. So this is a definition for camera pins here. Further underneath actual code, DHT pin is defined on pin number 2, and that is DHT11. And for LDR, pin number 33 is defined. Pin number 2 is a digital pin, and pin number 33 is analog pin. After that, I have defined constant for light intensity calculation. So this is taken from datasheet of this particular module, and this is a time delay for taking measurements in between for light and temperature and humidity. This is a configuration for Wi-Fi. So instead of using Wi-Fi to stream my video, I have used ESP-32 as a access point, so that way I don't have to connect it with Wi-Fi. Instead, I can connect it with ESP and use it as access point. So here is a ESP-32 AP as a SSID and password as a generic password, and it will configure my local IP and gateway as shown here. Furthermore, this is a code for actual communication. Once access point Wi-Fi connection is established, it will configure my camera pins. Once it is established that camera has been set up correctly, it will further go into sensors reading. So once it is confirmed that camera is working and we have a successful connection on particular SSID IP address, we will take measurements from DHT11 and LDR, and then we're gonna print it out on command window here. So for example, if I connect my project to a computer via USB-C, so first of all let's connect it. So as you can see, now it's connected with USB-C, which is I'm gonna connect it with my laptop. So as you can see that it is giving a reading from a few sensors such as DHT11 and LDR on command window. Now let's explore on user interface side. So for user interface I have utilized Node-RED. So first of all let's open Node-RED on my laptop. So as you can see in Node-RED screen that it is showing COM6 is not connected, and that I realized that it is because it is connected with Arduino IDE, so I have to close that first, and then we're gonna retry to connect on COM6. So let's remove this USB connection and plug it again. So now as you can see that it is connected successfully. Before we jumped into actual product, let's first explore what I have developed as a brochure for this product. So as you can see that this is an enclosure from both side isometric view, and this is from bottom view, and this is from top view, and this is my user interface, which I will show you in a moment. And as for connection of sensors, DHT11 is connected on pin number 2, and light intensity sensor is connected on pin number 33 as I mentioned before, and both of these sensors are accessible from outside without opening this enclosure. And for measurement I am utilizing a gauge interface. So for humidity it will measure from 20 to 90%, and same for temperature, it will measure from 0 to 50 Celsius and 32 to 122 Fahrenheit. And for light intensity it will measure from 0 to 1023 lux. For video I have few options in user interface to control to get resolution from 96 by 96 up to 1600 by 1200, and it has few options for face recognition and quality control such as brightness and contrast, and also it has special effects and frame mirror and flip. We're gonna explore these features in a bit. So Now let's jump into node rate. So this is my flow here for node rate. As you can see that I am getting values from sensors on COM6, and once I open it, you can see that I have established a baud rate as a 115200 on COM port 6. This is getting fed into a function that is splitting my values into 4 separate values, and each of these values is fed into particular gauge for humidity, temperature in Celsius and in Fahrenheit, and for light intensity. So for humidity I have from 20 to 90%. For temperature in Celsius I have from 0 to 50 Celsius, and same for Fahrenheit I have from 32 to 122 Fahrenheit, and for light intensity it is from 0 to 100 and 120. And for video streaming I am utilizing my web address as 192.168.4.1, which has been set up for access point on ESP-32, and we gonna get our video streaming on this address. And this is a generalized setting for frame. So once I deploy this, I will get user interface on node rate dashboard. So this is node rate dashboard, and before I forgot to connect it with access point, so let's connect it with ESP32. So this is access point, so I will connect it to access point. So as you can see from here that it is connected to ESP as access point, and we are getting some humidity and light which is quite bright because of I'm facing a window. So if I cover it little bit, as you can see that it is getting varied. So for light intensity, as I mentioned in my brochure, that if light intensity, or for matter of fact if any of value for any sensors get more than, if it gets more than range of gauge, it will still show up underneath gauge as a text, but gauge will be saturated. So for example, if I remove my hand from light intensity sensor, it will be saturated to its maximum, and you will see that it is giving quite high value for light intensity. So if I cover it with my finger, it is giving a low value because light is entering in low measurement inside this LDR. But if I remove my finger from it, it is giving quite high value. And same for humidity, and so this is a DHT11. So if I hold it with my finger, you will see that it is changing. Gauge for temperature is changing, and same for humidity. So if I hold it, humidity is increasing from 49 to 55, and temperature is increasing. Same It is increasing slowly because variation in this environment aspect is slow. But as you can see from humidity that it is going quite high now. It's almost 73 and temperature is 27. So if I remove my finger from sensor, that you can see that light intensity jumped quite high because I'm sitting near window, and we should get temperature and humidity slowly decreasing, and it is decreasing for a fact, verifying that both of sensors are working correctly. And for video streaming, as I mentioned in my brochure, that we have quite few options to choose from for video streaming. So first of all, I will just start streaming as a basic 320 by 240 for resolution. So let's start streaming, and as you can see from here that it is giving us a live stream. And if I change my resolution to maximum, as you can see that I'm getting quite high resolution from my webcam. Same for, I have few other options which I can vary depending on my usage, from 96 by 96 to as high as 1600 by 1200. That's maximum resolution I can get from this webcam. And for quality and brightness, I can vary it from here. And for special effect, we have negative, we have grayscale, we have red tint, green tint, blue tint, and so on. We have few more other options that's gonna be for accuracy of webcam. So as you can see from here, it has some gain ceiling, so it will make sure not to saturate at some certain color resolution. And for lens correction and for horizontal flip, so if I click on horizontal flip, my video is getting flipped, as you can see from here. So let's try it again. So it is right now screen is facing like this, and if I put on edge mirror, it's mirroring my whole screen in horizontal direction. Same for vertical flip. If I can flip my frame without rotating my camera, so for say if my product is fixed on certain angle, I can change my frame. For color bar, it will give me bars of color, so it's giving me as a some whatever is utilizing in on my screen, it is giving me that colors particularly. And same for face detection and for face recognition. We're gonna explore more about face recognition. So if I turn it on, it is giving me lower resolution. It asking me to do lower resolution because of it has a lower capacity, so I would select HP, and then we're gonna try recognition. Still asking for less resolution, so I would go for 320 by 240. I think this is good enough, and then we're gonna do face recognition. So as you can see in the screen, that if there is any face, for example for mine, it will recognize as a face, but for other things it will not recognize. So this is quite good features to have for webcam streaming. So we're gonna stop this face recognition here and face detection. So as you can see that camera is not that perfect, but still it's good enough for webcam monitoring. And this is all for my project. Thank you.